Okay, and so we're going to go over LAB1 now for 4670. And like I was saying, you could do this in either Packet Tracer or GNS3. Let me just take a real quick poll here. What would you rather see it in, Packet Tracer or GNS3? As I asked my class this.
Let's try GNS3. I've never seen that.
Okay, I see. I hear one GNS3.
That's fine. I don't either.
Ah, GNS3. Okay, cool. So GNS3 is going to be a little tricky, but it's all right. No. It's just it's gonna be harder. But this is a good lab to do in GNS3. So so again, I'm gonna assume that you already have GNS3 running installed, and we're gonna spin it up. We're actually gonna put in not one router, but 3 routers, and let me show you how this is gonna work. So I'm gonna come up here and do a new project. I'm just gonna call it lab-1. Click OK. And then on my router tab, I don't want to do a new version. We'll do that later. All right, I have a 7200. I'm gonna drag that over here. Okay. Now I'm gonna go in and look at the configuration of this router. I'm gonna look at the modules and slots. I'm sorry, the slots. Okay. I'm gonna modify this slightly if I have a device to do so, and I don't. Okay, so that's all right. Let me just take a real quick look here and see if I can find I'm going to pause the Camtasia Studio. So I had to go in and put an additional iOS, and this is a good example where we can load that iOS. So once you download it, if you go back to your preferences, edit preferences, you can put in another iOS router. So we'll go to iOS router and then new. Okay, make sure I'm recording here. Yes, I am. And pops up right there. So you see I have that 3745. That is the one that I downloaded. Okay, you're going to click new image and browse to that 3745. Okay, so I put it on my desktop. There it is. Click open. Would you like to decompress it? You're going to say yes. It'll create an image file for you. All right, there's no chassis. So this is important though. This is an Ethernet switch router. For the purposes of Lab 1, you want to check that box. And all it's going to do is change the name. And it's going to apply a switch module. Okay? So we're going to click next. Keep the default RAM, everything else. And what that does is it puts that NM-16 ESW, that's a 16 port Ethernet switch module. And that's all we need for now. So we're going to click next. We're not going to put anything else in there. We can do the idle PC. That'll help us out so that the processor doesn't scream at us. All right, so once it does that, we can finish. There we go, we're all done. And now we can go over here to routers and we should see, wait a second. It's not going to be there. It's actually going to come under here under switch. See where it says Ether switch router? That's where it showed up as. Okay, so it's not under routers, even though it was an iOS router that we did. Since we checked that Ethernet switch box, it's under the switch icon, and it's this Ether switch router. So we're going to drag that over here. And then we're going to drag a second one over here. And that looks similar to what we have on our topology. So what we need to do next is we need to start connecting everything up. So what we're going to do is when we boot the systems and console into them, ensure the software boot is performed, a password recovery if needed. That's just a give me. This is if you're doing it with actual real hardware. We're going to give the router a host name of R1 and the switches a host name of SW1 and SW2. But before that, we need to cable everything up. So to do that, we have a little cable icon over here, add a link. We're going to click on that, and our cursor changes to a crosshair. Start with the router first, and I'm going to go with the gigabit connections. So gig 10, I'm going to put in here to, you notice that we have a little bit something different here. Our ports are numbered 0001 and then 10. The ports that are numbered 10 through 115, those are the actual Ethernet switch ports. So you need to connect to one of those. So I'm just going to connect to 10. And I'm going to connect 20 to fast Ethernet 10 on that side. When I'm done connecting everything, I'm going to come over here and turn my cursor back to normal. All right. And now I just need to turn everything on. So if you come up here to the start resume all nodes and you click it, it will turn everything on. And I'll take a minute or so. And now you can see the boot process if you right click on any of the devices. So if I right click on the switch here and I go to console, okay, I'm now in a terminal session with it. It's booting up still. There it goes. Those are all the interfaces that are coming up. I want to do the same thing with ES2 and with the R1. So R1 already has the right host name. So we don't have to change anything. Okay? But with the switches, we need to go in. So this is ESW2. I said I wanted it to be what? SW2 and SW1. So we got to change the host name. So we go into global configuration mode. This just like packet tracer, what you did last week. And then host name is the command, and then SW-2 because I'm on switch 2. You'll see the prompt change. And then on ESW1, same thing. Conf T, host, SW-1. Now, there's a little something different with working with the iOS and GNS3 than there is with working in packet tracer. If I were to turn everything off right now, if for some reason my system was to reboot, I'd lose everything. So a good hint, write early, write often, okay? Save your configuration. So the easiest way to save your configuration is if you go out to privilege exec mode, WR, okay? Or WR MEM, right? Or copy run start, all right? But every iOS that I've worked with since like 8 dot something, WR will do it. It'll write it to memory. Okay? Okay? So do that so in case you need to shut down, save, go to lunch, you know, go see your grandma or something, I don't know. You can come back and you can be back exactly where you were. All right, so let's press on. Now that we have the topology done and we have the routers up and running, all right, the rest of it should look kind of a little bit similar because a lot of it kind of follows homework 1 and homework 2. We need to set up the following users: username admin, password Cisco, privilege 1. Okay, this is on all devices. So I'm on switch 2, username, admin, priv1, secret, Cisco. Right? Yeah, that's it. And username root, password root, privilege 15. User root, priv 15, secret root. There's no complex password complexity rules. So go through that and do that on all 3 devices. Okay? I can't give you everything. You got to do some work. This is college after all. All right? So on R1, we're going to give the link to switch 1, the IP address 192.168.20.1. And on the other interface, we're going to give it IP address 204.186.29.1/29. So if you remember, I had gig 10 going to switch 1 and gig 20 going to switch 2. So let me get to R1 here. Int G1/0. Now, if you're ever confused and like, oh God, what did I connect up to? Well, here's an easy way to cheat. If you come up to your topology in GNS3 and you put your cursor right over any of these green dots, it'll tell you what your port is. So it's gig 10. And I'll tell you what it's connected to. It's connected to fast Ethernet 10. Okay. So now that I'm in the interface configuration mode, I simply give it the command to add that IP address. That command is IP add, the IP address, and a subnet mask, which a /24 is 255.255.255.0. Any questions on that? Yes.
Would WR and WRMF be the same command?
Yep, they exactly are the exact same type. Okay. And after that's done, now we have to turn the interface on. So to turn the interface on, if we look at the configuration and we look at that interface, we see that we have the IP address and that it is shut down. So how do you think we get that interface to work? Huh? No, I'm already in the interface. So if I control Z out, I'm still in the interface configuration mode. What command do I use to turn it on? No shut. Why no shut? Because shutdown's already in there, right? So to take any command out of the configuration, you just go to wherever that command is and you put no in front of the command and it disappears. So now we do a no shut. We're going to get a syslog message because we're in the console, because you're going to see the interface come up as you see right there. But if we control Z out or we look at the running config again, you'll see that, oops, that shutdown command is gone. Okay, we do something very similar with the other side. So with gig 20, which doesn't have an IP address, we'll go into it and we got to give it the 204.186 address. Config T, int G2/0, IP add 204.186.29.1. Ooh, what's a /29? Told you guys you need to know CIDR notation when you get to my classes. What's the subnet mask for a /29? I'll give you a hint. It's 255.255.255. something. 248 is correct. And we have to do that no shut command again. So I'm just going to page up there to where I did it before, hit enter, and we'll get all the commands there. That'll run through that. All right. So with that, where are we at here? We did number 4. We need to set up VLAN 10 and VLAN 20, excuse me, on the switches. So this is a little tricky if you haven't worked with switch ports before. So here we're going to set up a VLAN, then we're going to set up an interface for the VLAN. We're going to address it, and then we're going to assign the port that we're have connected to the router to that VLAN. Okay, so I'm going to start with switch number 1. And then you guys are going to do switch number 2, because it works the same way. So on switch 1, we need to set up VLAN 10. Okay, and set up an interface with that IP address. So let's go into, well, actually, to set up a VLAN in some switches, you actually have to go into the VLAN database. All right. Others, I think you can do it with this train of iOS code. You just have to start a interface with that VLAN number. So if I do a show run, you look at all the interfaces, you see all the fast Ethernet interfaces that are listed there, the same stuff that you saw, and you have one VLAN interface and it's shut down. Well, there is no VLAN 10, is there? So we got to make it. So config T, interface, VLAN, space 10. Wow. Wasn't there before, it is now. So what happens when you do that is it's supposed to create an actual VLAN in the VLAN database. So let's put the IP address on it first. So IP add, because we're in the interface, and that was going to be .254, I believe. Yeah, .254. .20.254. All right. And let's do a no shut, because I believe it comes up as, oops, that. I got to be really careful, because if I start typing in no shut and I fat finger the command, you can imagine if I switch a U with an I, it's very embarrassing. Not everybody gets that humor, but that's okay. So show run. It'll be at the bottom. There it is. There's the IP. Perfect. So now we can make sure that it's in the VLAN database by just doing a show VLAN. Or VLANs. No virtual LANs configured. Oh no. All right. So with older switches, you have to go into a database called the VLAN database. So if you type in VLAN database, you go into VLAN configuration mode. Then all you have to do is type in VLAN 20, in this case VLAN 10, and then you rename it if you want to, or you just keep it the way it is. It's fine. Exit out. Now if I do show VLANs, oh, I don't have it set up for on .1Q. All right, don't worry about that. Scratch that. Scratch that. Let's go into the interface. Config T int f1/0, which is connected to the router. All right, now this interface as it is right now is a layer 3 interface. So we could put an IP address on it, we could route with it, etc. We may need to make it a layer 2 interface. So That is done with the command switch port. Okay. And any switch port command will shift it over. So we need to make this an access switch port. An access switch port means that there's an end device attached to it with like an IP address. If it were a trunk port, we did switch port trunk, that tells us that that's going to be another switch on the other side of it because we can have multiple VLANs that go across that trunk. So switch port mode access, and then switch port access VLAN, and then what VLAN is going to participate on this switch port, which in this case is VLAN 10. And that's it. Yep. So do a show run. Okay. The duplex and the speed are automatic, so don't worry about that. And then VLAN 10, the interface. Oops, look at there, came up. Perfect. So now we should be able to ping ourselves and, if I did everything correctly, our router. So you have to do something very similar on switch 2, but instead of VLAN 10, it's going to be, guess what, VLAN 20 over on that switch. Don't worry, you got a couple more weeks left to go. All right, so moving on. So that was the setup of the VLANs. On R1, we want to set a default route. So here we're going to put in a static IP route on R1. And that is done in global configuration mode, so I need to get out of the interface that I'm in. And the command is IP route. And a default route is what type of a route? It's an all zeros route, meaning it catches everything that doesn't already have a destination or a route in the routing table. So it's one of the simplest route statements to do. 0.0.0.0, 0.0.0.0, and then the destination, which I gave you the destination in the question, which in this case was 204.186.29.3. That's it. Enter. So now if packets come in and hit the route engine on the router, it's going to have a place to go because there's a default route there. It's also called a route of last resort, or a gateway of last resort, I should say. Number 7, set up DHCP on your router. Okay, so here we need to support the 192.168.20 network. All right, excluding 1 through 25, usable addresses 26 through 253, and exclude 254, and give it a DNS server of 20.16. So setting that up, not too terribly difficult. We need to go into and make a DHCP pool. So IP DHCP dash server. I'm sorry, IP DHCP pool, and then a name. So I'm just going to put in clients. That's arbitrary. All right. And then I tell it what network is going to be participating in. So network 192.168.20.0, because it's the whole class C. Let's subnet mask. All right. Now, I'm gonna skip over these three, A, B, and C. I'm going to set up the DNS server real quick. So it's DNS dash server and then the IP, which in this case is 192.168.20.16. All right, and that's it. Now, well, you didn't exclude any addresses. Well, that's right. It's not done in the pool. It's actually done outside of the pool. So if I exit the pool and then I type in IP DHCP excluded dash address with the lower address and the higher address of the exclusion, 192.168.20.1 space 192.168.20.25. I have one left, all right? I got 254. Up arrow. That's it. So if we look at the show run, you'll see that the exclusions are there, and then the DHCP pool has the network and the DNS server. It's going to assume that the default router is the IP address of that's on that interface. You can statically assign the default gateway router by doing a DHCP option command in the pool. Yes, Kyle, what's your question?
I was just curious as to why they didn't have it done in the pool. Like, why do you have to go outside of the pool?
Why they have to go outside the pool?
Yeah. Like, since you weren't able to put it in the pool of clients, you had to do the exclusion on the outside of the pool, right?
I don't know. I don't know who programmed this daemon in iOS back in the 1990s. So the question, for the benefit of the people watching this on YouTube, the question was, why do they do the exclusion outside the pool and not inside the pool? And my response was, I wasn't around at the time when they wrote the code. Otherwise, I'd have told them to do that because that does make the most common amount of sense. But hey, something we got to remember to do. Okay, or hence, in short, I have no earthly idea. Okay, so number 8, set up a standard access list on R1 to deny any IP traffic from that network inbound from the public interface. So first off, which one's the public interface? This is kind of a trick question. Which one's the public interface? Is it the one to, let me pull up GNS3. Is it the switch 1? Is it the switch 2? You guys are already thinking too hard. Huh? Nope. Which one has the public IP? Switch 2. All right, because we put, did it show it there? No. So in the router, if we go back to R1, gig 20 has the 204 address. That is a public IP, so that's your public interface. Hence, that's where we're going to put the standard access list. So a standard access list only works off of source IP address. That's all it cares about. It doesn't care about where the packets are going. It only cares about where they have come from. So easiest way to do this is just to do a simple numbered access list. So a simple numbered access list, as you will learn here in the next chapter, chapter 3, is numbered 1 through 99. So the command access-list space 10 deny, because we're asking it to deny traffic. From 117 to 23.54. So 117.23.54.0. Now, here's how access lists work. They don't work off of a subnet mask. They work off of a wildcard mask, which is an inverted subnet mask. So instead of 255.255.255.0, in a router, it's 0.0.0.255. Now, guess what? You're going to learn this for routers, and then when you go to firewalls, I'm going to say, you know what I told you about access lists and routers? Forget it. In firewalls, it's actually normal. Hey, Cisco has to have trick questions for the CCNA exam. This is one of them. Okay, so we put that deny in there. All right, so good. Who thinks that's good? Who thinks it's not good? Okay, it's not good, and here's why. At the end of every access list, standard access list, extended access list, there is an implicit, meaning an implied, deny all. So we put that up there. Guess what we have immediately after it? It's not seen, it's not written, it's an implied deny all. So we're going to deny traffic from that network, but guess what we're also going to deny? All traffic. So we've got to put a permit any in there. So I'm going to put in that's the up arrow, permit any. There we go. And I'll do a show run. There it is. That's what I'm looking for. And last but not least, we've got to go into that gig interface and apply that access list inbound. So we'll go back to int g2/0, and you do that with the access group command. I'm sorry, IP access group command. The number of the access list, which in this case was 10, and the direction of the traffic, so it's coming inbound. There's either inbound or outbound, so this would be packets coming into the interface. Look at the running config again. I'm running out of time. There it is. Okay. Number 9 and number 10. So number 9 you can do on your own because this is kind of a repeat from homework 1, setting up SSH. Same steps that you did in the first homework. Okay? So with number 10, in locking out your aux port, disabling your HTTP engine, setting your console password, everything else, turning off Cisco Discovery Protocol. I'm going to go through this really quick because I can do it in like 2 minutes. Now remember, I'm doing this on R1. Number 10, you've got to do it on all devices, the switches, the router, everything. I will go through each one of these individually. And what happens to a lot of times to students is they get done with R1, they feel happy with themselves, they turn it in, and they realize that, oh, geez, I probably lost like 8 or 9 points because I didn't do it on the both switches. I only got like 1/3 of the points for that question. Don't let that happen to you. Also need to turn on service password encryption. All right. No CDP. Run. No CDP run will turn off CDP. On the aux port, if I go into line aux 0 and do no exec, that basically locks out the executive of the line. It's unusable. What else did I have you do? I turned off CDP. I disabled the aux port. Oh, disable your HTTP engine. No. Oops. Go back to global config. No IP HTTP dash. I'm sorry, space server. That turns the HTTP server off. But guess what? There's 2 servers. There's an HTTP server and an HTTPS server. Oh, it's going to make a liar out of me. I guess not in this iOS train. Oh, no HTTP secure dash server. That's what it was. Turn that off too. Set a password on your console port. So I already disabled CDP. So line con 0, login, local, password, Cisco. There you go. That's it. Done. Piece of cake. Right? All right. I always look forward to seeing how many views I get on all the labs when I upload the videos, because I'll have that one or two students, and I'll see, especially when it comes to like when the assignments are due, I'll see my views go from like 520 to 100 or something. It like jumps up really fast. So I was like, oh, okay, that's fine. All right. Huh? Yeah, 29th. All right. Cool. Well, I'm gonna sign off on the video. I will get this uploaded here ASAP. So thank you guys very much.